In this video, we're going to talk about slope of a curve. So we have a function f of x, that is a blue line, blue curve. And you have 2 points, f of a plus h, and f of a plus h. So slope of this secant line is pretty easy to find. But what about if you want to find the slope of this tangent, which is a red line, at that particular point, f of a? That's what we're going to talk about. So let's say you have x value, and the y value of that point will be f of a. Now there's a distance h. So this x value right here, this is a, here's h, so that will be a plus h. And what is the y value when x equals a plus h? That is f of a plus h. So you have to understand how they got a plus h and f of a plus h. So what is the slope of these? So what is the slope of the line that passes through these 2 points? Well, the slope will be delta y over delta x, change of y over change of x. So it's going to be f of a plus h minus f of a plus h minus f of a, all over a plus h minus a. So when you simplify that, you're going to get f of a plus h minus f of a, all over a cancels out, you get h. Now that looks very similar to this part right here, right? Now we're going to talk about where does the limit of h approaches 0 comes from now. Remember, our goal is to find the slope of this tangent line. Slope of this tangent line at that point, a comma f of a. So what's going to happen if we let h get smaller? If h gets smaller, notice this point, that point right here, as h gets smaller, it's going to get closer and closer to point a comma f of a. Think about it. If h gets smaller, the point will end up over here, over here, over here, and so forth. So our goal is we're going to make h very close to 0, so small that this point will be almost like a single point. That's the concept of limit as h goes to 0. So when you do that, that will be so close to 0, it's like finding a slope of this tangent line at that particular point. That's why the slope, tangent slope, will be limit of f of a plus h minus f of a all over h as h goes to 0. Now let's take a look at this example here. They want you to find the equation of this tangent line at 2, 4. So what we need to do is we need to find the slope of a tangent at 2, 4. So in this case, our a is 2, and our f of a is going to be 4. Because that's the point of a tangency. Now, you know that the slope is going to be limit of f of a plus h minus f of a over h as h goes to 0. So what is our f of a plus. So instead of instead of a, let's plug in 2. Now you know that f of x is x squared. So what is f of 2 plus h? Well, that will be, instead of x, you got to put 2 plus h. So when you multiply this out, 2 plus h times 2 plus h, you will get 4 plus 4h plus h squared. Now what about f of 2? That's what we need, f of 2. Well, f of 2, when you plug in 2, you're going to get 4. Okay, so let's keep this in mind. We found f of 2, and we found f of 2 plus h. Now let's plug it in. We're going to get limit as h goes to 0. What was our f of 2 plus h? It was h squared plus 4h plus 4 minus f of 2 was 4 all over h. Now let's find the limit. So well, 4 cancels out. And notice, h will cancel out. So you're going to get h plus 4. Because h squared divided by h is h. 4h divided by h is 4. Now let's plug in 0. What happens? You're going to get 4. So that means 4 at that point, the slope of this line is going to be 4. Now, how do you find the equation of this tangent line? Well, we have a slope. Remember, if you want to find the equation of the line, you need a slope and you need a point. Do we have a point? Yeah, that's 2 comma 4. Now we're going to use a point slope form to find the equation of the tangent line. So the point slope form will be y minus y1 equals m times x minus x1. So let's plug it in. This is like your x1 and that's your y1. You're going to get y minus 4 equals 4 times x minus 2. Now, this is good enough, but if you want to simplify further, then this becomes y minus 4 equals 4x minus 8. So you get y equals 4x minus 4. This is a point slope form, and that will be a slope intercept form. So basically, when you graph x squared, and when you graph y equals 4x minus 4, you'll notice that 4x minus 4 will be a tangent line at x equals 2 and y equals 4. Now, what if there is a line that is perpendicular to this tangent line at x equals 2 and 4? We call that a normal line. Okay, normal line is a perpendicular line that goes through that point to the tangent line. The slope of a normal line will be a negative reciprocal of the slope of a tangent line. So since the slope was 4, this normal line right here, the slope of the normal line will be negative reciprocal, which is negative 1 over 4. And we'll look at an example. So this example said we need to find an equation for the normal to the curve f of x equals 4 minus x squared at x equals 1. So in order to find the normal to the curve, we need to find the tangent, slope of a tangent line. So we know here we know that a is 1. And what is f of a? F of 1. When you plug it in, you get 3. So f of a is 3. So basically, in order to find the slope, we got to find limit as h goes to 0 of f of, what is our a? 1. 1 plus h minus f of 1 over h. So since f of x is 4 minus x squared, you know that f of 1 plus h is 4 minus quantity 1 plus h squared. So you're going to get 4 minus the quantity. When you multiply this out, you're going to get 1 plus 2h plus h squared. Distribute the negative. You're going to get negative h squared minus 2h plus 3. That's going to be our f of 1 plus h. Now, what is f of 1? Well, f of 1 is going to be 3. That was our f of a. So let's plug it in. Limit as h goes to 0. So you got negative h squared minus 2h plus 3 minus f of 1, which is 3, all over h. Well, 3 and negative 3 cancels out. And look, you could divide both of them by h. So you end up getting negative h minus 2. So when you plug in 0, you're going to get negative 2. So that is a slope. That is the slope of a tangent line. However, we want the normal. You know what? Let's find the equation of a tangent line. You don't have to, but let's do it. So using the point slope form, y minus y1 equals m times x minus x1, you are going to get y minus 3 equals negative 2 quantity x minus 1. And this is good enough. That's the equation of a tangent line. But we want to find the equation of a normal line to this function at x equals 1, y equals 3. So the slope of a normal line will be negative reciprocal, which will be 1 over 2. And it will go through 1 comma 3. So it will be y minus 3 equals 1 over 2 quantity x minus 1. So this is an equation of a normal line to this function at x equals 1 and 3. Now let's graph f of x and these two lines and see what happens. So using TI-84, I put the y1 as a function. I have an equation of a tangent line, and I have an equation of a normal line at x equals 1. So let's see what happens as we graph. As you graph, it doesn't look like perpendicular. This is a tangent line and normal line. So what I'm going to do is I'm going to go to zoom and press 5 for zoom square. And let's see what happens. So now it kind of looks like a perpendicular. So again, at x equals 1, and which means the y value is 3, this red line right here is the tangent line. And black line is the normal line at x equals 1 to the function.